What's up, Sid? I can't hear you. Hold up, hold up. Try speaking now. Have you already done lab 4, bro?
Hello. Hey Chad, how are you?
Good.
Okay, yeah. Let me 1 second. I think yeah, we can wait for a couple of minutes for other students to join, and then we can start.
Sounds good.
So you had lunch?
Just got back from lunch. Yeah. West Coast time, man.
Nice.
You guys 3 hours difference?
Yeah. You got your vaccine?
I did not yet. Did you get it?
No. I'm planning to get it next week.
Yeah. I think California now has enough for everybody.
Yeah, exactly. Yeah. Giovanni was saying the other day that entire lab was planning to have a get together at his home.
I wasn't invited.
No. It's about to, like, he was planning. It was not didn't happen yet.
Are you coming back for it?
No, depending on when it happens.
Yeah, you're a big professor. You got all sorts of money to just fly around the country.
No, but I need to get vaccinated first, right? So, Chad, do you mind if I record the presentation?
Yeah, go for it.
Okay. Okay, I guess I think we can start. Hello, everyone. This is Chad. He's the founder of Authenticate, like one of the amazing techniques that I have worked on, and like it allows you to authenticate with anything that you can think of. So I think Chad will explain you more about those things. But yeah, so what we learned in our class are like the things that are like theory, like what happens on the paper, but you'll now understand when you go to the real world and try with real open source software, what are the things that you would face, and other intricate details. Okay. Yeah, Chad, go on. Yeah, floor is yours.
Yeah.
Can you share
I have some slides. I got a screen share.
Okay, can you share the screen? Well, let me allow you.
It says host disabled, screen sharing. You got this thing locked down, man.
I never learned Zoom.
Yeah, me neither.
Okay, I think you should be able to share your screen.
Back when we went to school, we didn't need Zoom.
Yeah.
All right. Hopefully this is presenting.
Yep.
Yes. All right. So hello, everybody. I don't see your faces, but I assume you're looking at me. I wasn't exactly sure what Arvind wanted me to present to you, so I gave a couple talks to a software engineering class a while back called like software engineering through the eyes of a CEO and a hacker. But this one I think is more, to show you guys what I've learned after leaving school and what the real world is like. So the agenda for today, first I'll tell you a little bit about what I do. So why I'm interesting or not interesting. You can be the judge of that. And then some things that I wish I knew when I was that when I was a senior or junior in college that I just kind of took for granted, and old people told me things and I ignored them. And then some of my thoughts on just operating systems in general, since it's an OS course. My company, we deal with every single operating system. My thoughts on bugs then and now. So what I used to think bugs were and what they now mean in my life. And then just some final takeaways from, starting a company and, generally being a computer scientist, a working professional. And then I left plenty of time for Q&A. So hopefully we can have some good discussion. So my journey started in the 90s. I was an internet pirate, a hacker, tinkerer. I don't know, I was one of those people that was always soldering things and breaking stuff, catching things on fire. I went to college at Pitt. After that, I went straight to my PhD and ended up dropping out at the University of North Carolina, Chapel Hill. I dropped out to go get a job at MIT Lincoln Laboratory, where I did research for the Department of Defense. Then I came back to finish the PhD. That's where I met Arvind out here in Santa Barbara. I started doing hacking a little more seriously there when I joined Shellfish. And then now I started my own company and have been doing that for the past 2 years. So what my company does, we're called Authenticate. So the idea is that we want to create a security product that's not a pain in the butt to use. That's pretty much the goal of our company. And like Arvind alluded to, authentication is kind of the thing that frustrated me the most, typing my passwords and just trying to, log into things every day. So the idea here is that we have a smartphone app where you can have this one credential where there's a private key on the phone, and you can use that to authenticate to anything, whether it's a digital thing or a physical thing, like a car or a door, and it can support any interface. So it doesn't matter if it uses Bluetooth or Wi-Fi or USB connection. And then the whole point of it is that it's resistant to software-based attacks. So that's kind of the interesting computer security aspect of it. So the idea is that you have your phone, you interact with the world as you normally would. You walk up to a door, you walk up a computer, you log into a website, and all the interactions are the same, but now you get a prompt on your phone, you answer on your phone, off you go. You don't have to remember anything, you don't have to do anything special. And the architecture does this in a way that we ensure that the user pretty much cannot get it wrong. The security is kind of baked into it, and it's easy to use. So where that comes into this class, if you guys are learning operating systems, so what we did here is we built sort of a trusted layer that will go under the operating system. So we actually put this in Trust Zone or a similar trusted execution environment, and then we expose an API to the operating system, and then you can build whatever applications you want on top of that. But then as long as this API is locked down and secure, we can guarantee the security of the entire system. So we don't care what operating system you use. If it's a phone, a door reader, a computer, or server, it's irrelevant. We can run this code everywhere below the OS, and anything can interact with it without compromising the security. The features that we use, we need a way to talk to the user in a secure way. So on a phone, that means we take it over the screen and hardware, make sure nothing can intervene. We have a trusted execution environment. So this is a way where our code is executing and nothing else can execute. So even if the OS is compromised, they can't mess with our execution. And then a secure element. So some place to store credentials that's physically secure. So anti-tamper and all this cool stuff baked in, that even if you were to dissolve this thing in ACID, you wouldn't be able to get the key out. The interface this is what our app looks like. You literally just sign up on the website, verify your email, and then as you walk around your company, you'll just see things popping up and you can interact with them. You can unlock doors, laptops, whatever. And then everything you can manage from this portal. So, admins at the university would go in, say, Chad has access to these buildings, these doors, these computers, bam, everything syncs to the phone. The university becomes their own credential authority, pushes all this stuff out. And even if the internet goes down, it's fine because it's a fully distributed system. So everything has its own access control list and is all point to point. So complicated to build, hopefully a pleasure to use. And then what this lets you do is really cool security things. So you can have policies that are really flexible based on time of day. So like our office will unlock automatically during working hours. After hours, you need a biometric on your phone. You can do things based on location where you could actually check, if this computer is on this Wi-Fi network, just unlock. Otherwise, require something. You can now delegate resources. So if I'm on vacation for a week, I don't want to let you use my office, no problem. If you come to visit Authenticate, I can give you access for a week. And then from the security standpoint, we can have it open if the phone's near, if a human is there, or we can check for the actual identity of the person. So that's Authenticate. Hopefully, we kill it and you'll see us popping up with Twitter and those other single sign-on guys soon. I don't want to go into detail about that, but I wanted you to have an idea of what I'm working on and how this relates to the stuff I'll teach you. So the biggest lesson I learned in my career, which I think I will just emphasize, is I kind of always pushed software engineering to the side and thought, I'm a scientist, I'm not an engineer. I need to worry about this stuff. Like, I'm just going to write code that works and that's good enough, right? Like someone else will do the software engineering. I was incredibly wrong on that. So I would advocate that earlier in your career than later, you should really start taking software engineering seriously. And I want to start with my definition of software engineering, which I believe is building software that is built to last, easy to share, and amenable to collaboration with long-term maintenance in mind. I would argue that this is not what anybody in college writes. I think you write, your homework and you get it done and it works and it passes the test. But the sooner you can get to this point, and I think open source software is a good motivator for this. So there's one thing to write code, have it on your computer, no one sees it. The second you put on a GitHub, you're open to criticism, right? Your friends can see it, trolls can see it, and they can tell you this looks terrible. So I would encourage you just to open source as much as you can to get that feedback and kind of put the pressure on you that no, I want to share this. I want to collaborate with people. And, hopefully this lasts more than a week. So some of the internals that we use here, as far as our software engineering, we have 5 distinct products. We have over 40 GitLab repositories written in most languages. We have Java, C++, Objective-C, Dart, JavaScript, CSS. We do a lot of SQL. Python 2 is officially phased out as of a month ago, but that was still there. Bash scripts. We do a lot of cross-compiling. So all of our security code, we write once and compile everywhere. So it's compiled on iOS, Android, ARM. We have the Apple M1 in-house, so we compile for that as well. And then we support every operating system, at least the popular ones. So, we work on Raspberry Pis, Linux machines, Macs, Windows, iPhones, even Chrome extensions. So quite a bit of, experience working with different APIs, different OS calls, things like that. We also manufacture all of our own hardware in-house. So we do our own PCB design, we do our own mechanical design, and then we get this hardware back. We have to write our own firmware for it. We have to be able to interact with it, unlock a door, turn a light on, make a buzzer boop, all those fun things. So we really every aspect of computers kind of hits home in this job. I can't just write Python code. I can't just be an electrical engineer. You kind of have to know a little bit of all of it to make this product work. We use a bunch of cool management tools. So these are things I don't think, you need to be at a company to use and that are useful. So there's a bunch of them just for tracking things. So the Jira, Asana, and Trello are kind of the historic ones. Notion came out recently. I think it's free for the public. It is fantastic. It's everything you'd ever want for tracking a project. You have your boards like you'd have in Trello. It's also one of the easiest to use wikis I've ever had. There's a bunch of YouTube videos on how to use Notion to just make your life better. You can put all your to-dos and things in there. And even class projects and stuff, I would highly recommend using something like this just to collaborate with folks and get used to, doing engineering in a way where other people know what you're up to. Obviously, we use GitLab and GitHub for the public stuff, GitLab for the private stuff, Slack, Discord, all the typical things. And then obviously, thanks to the pandemic, I say we suck at video conferencing, but we use it all. The actual stuff that we really like I said, Notion is great. GitLab with runners. So this is awesome. I didn't realize that you got runners for free. I don't know if GitHub has them, but what runners are is when you submit your code, it will spawn off a Docker container, which is clean Linux instance, and do whatever you told it to do. So you get free runners with GitLab. You can even have a free organization of your own, and you'll submit your code. It will make sure that it compiles and run test cases for you. Oh my God, it's fantastic. You can also put it on your own computer. So we have runners that are Raspberry Pis and Mac Minis that actually fire up automatically. We use G Suite internally for all of our stuff. And then we have a bunch of different hardware testing infrastructure that we build up. But back to the runners and what I mean about software engineering and doing this stuff earlier. I somehow went my whole PhD without doing any CI, which I think is a huge mistake. And if I could do it again, I would start, I would have been writing CI test cases from the get-go. So the idea, like I said, you deploy it, you upload your thing and it will test things. But then there's also CD, which is continuous deployment. So when we take something to production, it's literally, we just take a Git branch and merge it into master. The second we merge into master, it takes care of everything. It'll actually SSH into our servers, launch all of the new stuff that we're releasing, update things in the field, firmware updates, launch everything. It's awesome. And then we can use Git branches to have beta customers, our development branch, And we just use Git branches to monitor our whole distribution. Also, if you haven't used Netlify or a similar CMS for even just like your homepage, you're missing the boat. It's the same type of deal. You'll have a Git repo, and whatever's in that repo, it will compile and put on the internet for you. So Netlify is our CMS. So if you go to authenticate.net, it automatically puts it out everywhere on the internet, manages the load balancing, everything for you. You can also do linting in CI, which again, I was just writing garbage code my whole life. So we even have pre-commit hooks now that your local machine won't even let you submit something to Git unless it passes all of the linting, which means that it's formatted correctly. It passes all the static analysis tests we have built in. Like, oh my God, these would be like game changers in my career. So I'm just trying to share that knowledge that, if I came into grad school or into my first job knowing this stuff, I would have been a rock star on day one instead of fumbling around for 5 years and then being a doctor at the end. Submodules also I fought for a lot of my career. When you're developing large projects, these are like an absolute must. And then for all the CI stuff, like I said, you have branch dependent stages. Maybe development pushes internally, master will push to the public. You can do all sorts of awesome stuff. So what does a CEO do? A typical day, I try to exercise a little bit. Most of it is not engineering anymore, which is kind of a bummer. But projects come up and will just consume my day. So lessons learned, you should learn Git, like really actually understand it. Don't just use, some nice GUI that's built into VS Code, but actually understand what's going on in a merge and a rebase and what it means to cherry pick and stage a hunk and all those good things. I think just as a computer scientist, these are, skills that I undervalued in my career that would really help you. There's a scientific philosophy called test-driven development. I am convinced that is the correct way to program. So you're writing a function, you write the test in parallel with it so that when it's done, you know that it worked and you can mock out anything that you didn't want to mess with, which is amazing. So say you're writing, kernel driver or some weird thing where it depends on an operating system and that's going to require, a computer to boot and it might crash the computer. If you're building a test, you just mock out the response. You say, I know this thing is I want it to return true, so just have it return true, right? And then you write your little snippet of code, ignoring the whole big system, and then you can put in bad inputs and see what would happen without trying to get the system to do the bad thing. Yeah, I don't know how I've survived up to this point without doing this, but it's awesome. Like we interface with Google, but we don't want to hammer Google's APIs and we can't get Google to return garbage values, but with this, we can fuzz in whatever we want. The other thing that I think a lesson learned in my career is that you should practice computer science. I think it's weird. So if you think of an athlete, right, you're going to the Olympics. The reason they got to the Olympics because they practiced a lot, which means they did the skill that they were doing without doing the game, right? Like sprinters go to the gym, you'll just go and you'll bounce a ball off a wall forever. But computer scientists don't do that. Like when I talk to most computer scientists, they actually they program, right? And that's what they consider practice. But I really think you should take the time to do Vim exercises, get better at your hotkeys, open your IDE and actually just get better at opening windows, closing windows, do practice drills. Because if you say it takes you 10 hours, right? But it makes you 20% more efficient, you just saved 3 years of your life that you're not going to waste time clicking and hunting and pecking and that kind of stuff. Also, as an older person, ergonomics is important. Spend the extra $20, get a good keyboard. When your hands start hurting in your 20s, you really regret that. And computers are too cheap. I mean, get a good laptop. Don't fumble around on some slow computer that makes you miserable. This is your career. I would invest in it. The other lessons I've learned in my career, this is kind of the high grandiose things. I switched to a tiled window manager. I think it makes me, I don't know, probably 10% more efficient, not 10 times, but just not ever having to touch the mouse. I can just hit hotkeys. I also use 2 operating systems every day of my life. I use Mac for pretty stuff. So that's what I'm talking to you today on. And then I have a Linux machine for development and use software that lets me share the mouse. and learn your hotkeys. I pushed this off way too long. Again, I thought people that use Vim and Emacs were just old curmudgeons, but I spent, what, 2 summers ago, the whole summer, like learned Vim. Oh my God. Like I feel like for the first time in my life, I can use a computer. Like it is worthwhile. And pick your favorite IDEs and customize them. Like actually add the plugins you want, add the linters you want, the static analysis things that should be in there. Like this stuff, you just put the investment up front and your whole computer science career is going to be easier. And before you ever write a line of code, read the style guide, like know how you're supposed to comment in that language, and just do it correctly. You'll thank yourself and everyone will thank you down the road. And with that style guide, you want to be nice to the people you work with and to future you. So I think the biggest rule I have here, just because you can do something doesn't mean you should. So Python, I think, is a great example of this. I see programmers that will write insane stuff because Python can do it. You have all these cool lambdas and list comprehensions. So like this function down here will return the set of all subsets of its argument. But like, I mean, I think it would take 20 minutes for me to actually like really sit down and understand what's going on with the shift operation, like how this does what it does, when you could easily do this with like a couple for loops and some comments, right? It's like, don't write code like that. So back to operating systems, I guess, the point of this course, they're complicated, like no joke. They are absolutely one of the most complicated things you'll work with in computer science. So I'll give you just my high level take on the OSs that we work with every day. I think Linux is great. It's very extensible. We deal a lot with Bluetooth. It's got a pretty crappy Bluetooth stack, to be honest. Bluesy, we've had a lot of issues with it. OS X, on the other hand, has a great Bluetooth stack. In general, drivers on OS X are very nice, very clean, very well written because they own the hardware and the software, right? So you get a Mac and this interface is like, it's kind of magic at some points. It's like, it shocks me. I'm like, no way. I just told the kernel to do that and it did, 50 things for me. Windows, I don't know, jury's still out on Windows. I'll get back to you on my real thoughts on Windows. And then as an embedded systems company, we actually are using Raspberry Pis for now. So Raspbian is actually pretty good. It's not everything that we'd want. We looked into OpenWRT, which I was pretty impressed with as like a better kind of embedded OS if you want to get into that world. But none of them are great. Unfortunately, when you really get down and like deal with the low level and then modern operating systems, you're going to run into major frustrations in all of them. Like it's, they're all good for different things, but they're just such complicated beasts that ultimately there's some aura of mystery always. Where you're like, I made this iocto call and I don't know if it did what I thought it did. Looking at the mobile world, I do believe that Android overall is a better operating system, but iOS has a better Bluetooth stack. So currently I'm cheering for iOS, but as far as the OS goes, I really, really like the architecture of Android, their developer experience. Like it makes a lot of intuitive sense in my opinion. I really like the way they architected it. And the fact that it cross compiles for all different hardware and stuff is kind of, I don't know, maybe the most beautiful operating system I've seen as far as the extensibility of it. It's pretty neat. And yeah, this was a hard lesson to learn coming out of a computer security program. Bugs are inevitable. I mean, Arvin and I spent a lot of our PhD trying to find bugs, prevent bugs. And, then I started a company as, Dr. Chad Spensky, PhD in computer security. I'm like, we're not gonna have bugs. It's like we're gonna write perfect code. So that's not true, actually. The goal is not to prevent bugs anymore. I think just the complexity of the system we're writing, the type of logic bugs that can come up, all this stuff. So you pretty much have this loop of any product on earth, and then any company is gonna deal with the same loop. Step one, you wanna get detailed information about the bug or the crash. What is it? Step two, you need to reproduce it locally. This is sometimes very easy, right? Someone will tell you, oh, I was doing this in the app and the app froze. You do that in the app freezes, great. Then you have cases where only in production, we actually had this bug show up in one of our products, in our app actually, And only on Android, a certain function would fail in production mode only. So we would run it in development mode with our debugger attached, and it would work every time. We would then go to our customer and they'd show us that it's crashing. It turns out this was crashing because when you compile for release mode, it trims like it does tree trimming on your source code and found what it believed to be unreachable code and would trim it. That code turned out to be reachable and actually very important for our product. But that kind of bug, like finding this stuff in practice, that took like a week of my life. It's like mind blowing. You're like, debugger attached works, debugger detached doesn't work. Like, and then you find out that there's tree trimming and you have to add this @keep argument. So we do this, we reproduce it locally, then we fix it. Then you test the fix, then you deploy it. And the faster you can close this loop. So all the tooling that's coming out today, sort of the goal of every company is to close this loop quickly until we get to that holy grail where maybe we all use Rust and we have a bug-free future. I'm not sure, but logic bugs will always exist. We had one of those come up recently as well, where you could get our app in a certain state where it wouldn't check the value you entered and in fact would turn it to null, but only if you did the most bizarre thing ever. And luckily we had a customer that does bizarre things and they walked us through like how they registered for our app. And we're like, that doesn't make sense. Like there's 2 pages. How did you possibly do this in the wrong order? But the faster that you get this cycle down, sort of the better the products and kind of the world will be. And then I'll kind of wrap up with like open source, right? Love open source. So we use and contribute to a lot of open source projects. If you look at our GitHubs, you'll see most of them are kind of Bluetooth related. We actually have a merge request coming into BlueZ, which is the Bluetooth stack for the Linux kernel. It just didn't support functionality that in our minds should work because it works on every other operating system. So it will hopefully soon work on Linux. Yeah, and like I said, you really have to write great code if you're going to work for a good open source project and contribute to them. Most of their maintainers are very strict if they have a good project, and it makes you a better programmer, actually, like learning their style guide, learning to make sure you do tests, that when you submit this merge request, it's crystal clear, it's well commented, you know, and then going through the discussions with these guys, you get some really, really good insight. And just to get an outside perspective on work that you're doing, I think is fantastic. Like we've had issues that have taken us like 2 weeks to get merged in and had like, 10 different experts sort of chiming in like, oh, I don't know, I wouldn't do this. If you look at, the specification page number 537, you'll see that like this isn't supported natively. And we're like, yeah, I understand that, but you probably want to do it anyway for these reasons. It's really fun. And you meet really cool people. Like we've hopped on phone calls with these guys. One guy I think lives in France. So we're like, time zone was weird, but just like, once you get deep into one of these projects, it's great. Like you meet a good community, makes your code better. And for us, like we found some open source projects that have saved us like literally months of engineering time. They were like, oh, we need this feature. We're looking for something that does it. You find an open source project, bam. So that's why our philosophy is that we're using that project, I try to always give back to it in any way that we can. There's one recently we kind of took over. I'm not sure what they'll think of our merge request, but it went from like some guy's pet project to we kind of commercialized it. And our merge request is pretty much going to be like, hey, here you go. Like it's fixed. It's all better. And sorry, none of your original code's there, but the project you wanted now exists. So yeah, I would highly recommend getting involved in the open source community. It's been a good time. And all of our papers that we published in the Sec Lab, we open sourced all of that, which again, really sets the bar of like, do I want other people looking at this? Like, what are they going to think? This was an interesting lesson to learn as well, starting a company. I don't think you see much front-end development while you're in school. You typically build back-end things and they're all command line based, right? And they'll do some binary search trees or they run some threads, but ultimately just print to the screen. Yeah, I ran the thread, it exited, hooray, right? So I think this meme is pretty indicative of what actually happens. The back end is like this huge, complicated hodgepodge of things. And then you go to the website and it's like, beautiful, right? So at our company, at this point, everyone is effectively a full stack developer. So even the people we hired as like front end developers, like, hey, I do web dev, I'm going to do app development. I really think to understand and do that well, you have to at least have some knowledge of how both work. And the reason for this is you need a clean API boundary. So similar operating systems, anything you write, there's going to be some lower level that you need to talk to, and it needs to react appropriately and talk back to you. And if you really don't understand what happens, below that API boundary, it's going to be hard to write your front end well, or vice versa. If you're writing backend code and you don't know what the front end's capable of, it's not going to make sense, right? Oh, I gave you an integer back. Why is that not sufficient? Well, the front end wanted to display a picture. You can't display a picture with an integer. Give me a file pointer. Things like that. The boundaries that we cross in our company, they're kind of interesting. On our app, we use Flutter. So we have Dart to native code, and they provide what's called a method channel. So this, I have one guy that does all the front end development on our app. I do a lot of the native code development, and then we just have these predefined boundaries. So our app looks beautiful, and then under the hood, just makes a call, connect to a device. I do some crazy stuff, and then just pass back like, yep, you got it. One interesting thing about that is that all of the code we write now is asynchronous. So I think this is kind of a fundamental shift. Most operating systems will do the same thing. They're all asynchronous. But up until a couple of years ago, that was not the norm. But now, like, all of our Python code, Python 3 supports async, Dart, everything is async. So we're kind of moving away from threads, which, I don't know, in some cases it's pretty terrible. Performance-wise, it's not great, but as far, like, you won't have deadlocks. You can't get into these situations because the way async works. And then everything has to be callback based, which is kind of a different paradigm to program in. But I find it interesting. Then the other API we cross is like probably the most popular in the world, where you have JavaScript talking to some backend, right? So we use Flask, so it's Python-based backend. And then all of our websites and things have these really nice APIs. One cool takeaway on that, since Stripe was just in the news for being the most highest valued private company on earth, we actually use Stripe for our billing. Their API is incredible. Like, that company nailed it as far as this API boundary. It's really, really clean, well done. I don't know if they're secure. I assume so. Their like head of security used to work at Google. I have some connections to them, so I trust they're doing their job well. And then for our desktop app, we use Electron. So again, we're doing like JavaScript to Python over a Unix socket. And then we use Socket.io and Firebase Cloud Messaging. It's kind of these API boundaries that we cross. So to leave time for questions, I'm guessing this was an hour, so I tried to do half of it. I want to leave you just kind of with this idea of, with engineering in general, computer science, like, anything worth doing is worth doing well. So if you're going to invest time to build software, you should build things that people might actually use, right? I think I did myself a lot of disservice in my life of just building things to get them to work, and not building them with the idea that someone else will want to take this and use it. But if you get yourself in that mindset, then it's easier to practice, right? It's easier to actually take the time to practice your Vim key bindings, practice an IDE, and kind of build good software. Like, you'll take the time to write that comment, because it's like, oh, I'm going to open source this, and this could turn into a product, or this could be used by a company, or I could commercialize this. So I think if you just if you're actually going to take 17 hours or whatever, 40 hours to build a thing, build it well, because you never know what that could turn into down the future. So this company actually started as my passion project in 2008, maybe 2009. I was like, I'm sick of passwords. I want to use my phone to unlock my computer. How do I do that? And then just started writing crappy code. And then 10 years later, we're commercializing it and trying to turn it into a product. So yeah, if I would have written all the code from the get-go with CI and testing, we'd probably be a couple of years ahead of where we are. But the lessons were learned, and hopefully, lessons are passed down so you guys don't make those mistakes. So if you have any questions, happy to take them. And then my email is there. Feel free to reach out to me, anytime. Always happy to help Arvin students.
Thank you, Chad. That was amazing. So there are some questions in the chat. Yeah, can you see the chat?
Yeah, I can, yes. Yeah, okay. So the way that we do our audits, so right now we don't have anyone like pen testing us. So like when we release our code, my plan was to get some SecLabbers and incentivize them with some money, since we're already part of Shellfish, just say like, hey, can you guys take a peep at this? But as far as like software development, we have a policy in-house where no code can get merged without at least one other person looking at it. So even if it's a minor detail, say it's like, I changed these 5 lines for this reason, you'll submit a merge request, somebody has to look at it. Like no one person has the authority to say like, yep, this is important. And we've caught tons of stuff through that. And most of it is like me, because I think I'm smart. I'm like, oh, I did this cool, cute thing. And then someone will look at my code and they're like, Chad, you realize if we would push this, then like, anyone could log into our website. Not that egregious, but I get this kind of like, I get these cool ideas at night, I go to merge them. So I think that policy is really nice. Is Bluetooth safe and secure? So that's an interesting one. So I looked at this back in my first PhD and like the security of Bluetooth. To my disappointment, they actually do a pretty good job. Like I thought I was gonna find all these vulnerabilities and like the Bluetooth protocol is gonna be a disaster. The only thing that's a disaster about it is the pairing process is a mess. It's apparently probabilistic and there's not 100% chance you'll ever locate a nearby device, but it's asymptotic and you very likely will. We don't rely on it though. So we actually connect our devices over non-secure Bluetooth, so it connects faster. And then we encrypt our data on top of that. So you never act like the pairing prompt never comes up. So we give users a better experience. It just you install the app and it appears because we're not encrypted, so we don't need to pair. And then we handle the end-to-end encryption through that. So Bluetooth is relatively safe. There've been some exploits that have come out recently on the microcontrollers themselves, which I think are really interesting. We actually have a research project we're going to look at this summer. We were going to call it Bad Teeth, but someone came out with the title Bad Bluetooth, so we don't look like copycats. But there's a lot of, I don't think the firmware code itself, I think, is exploitable. And we found some interesting denial of service bugs where I think we can just like get the pairing prompt to pop up on anyone's iPhone and like just in a way that you can never use your phone. The biggest challenge I faced during transition from being a developer at a corporation to being a founder, CEO of a company. Oh my God, management. Yeah. So throughout my career, I got really good at like personal time management, right? So like I worked at MIT and I was at IBM Research for a summer. And, I'd come in the morning, I knew what my to do for the day was, and I would hammer it out. And, I wrote really good code and go home and everyone's happy. Same in grad school, I could write my paper, hit my deadlines, whatever. But now, like I have to hit my deadlines and make sure 8 other people hit their deadlines. And then keep track of all of their deadlines and make sure they hit them all at the right time so they don't block the other people. Yeah, I mean, that's been wild. Like, and just not even like managing people's time, but managing people's emotions and like, making sure everyone's having fun at work. And, is this actually a good place to work? Is this a good place to be a computer scientist? Like, are there enough snacks? Those kind of things that it's a really big transition because it's no longer just about, writing good engineering products. And then you have to become a salesperson and learn, taxes and things like that you don't when you're a developer. You just don't care. Like my paycheck comes in, that's fine. I don't care where the money comes from. Like I know IBM's good for it. Like the money will be in the bank. So yeah, I think the biggest transition from like more of a technical perspective is trying to lead a large project that's, going to take years, decades, whatever, and try and prioritize that appropriately.
Is it very similar to the TV show Silicon Valley? Is it like the experience you felt starting a company similar to that?
It is way too similar, actually. Like we watched that show and it's like, it's too dead on. Like, so we were a TechCrunch top pick. They got into TechCrunch. we literally had the problem where our customer was going to pay us with a check. And I'm like, I don't, just wait till we get our Stripe thing up, man. Like, I don't even know. Someone want us to write them a check. We don't own a checkbook. We're like, like, how do we pay rent? Like, I don't know. Can we Venmo you? Yeah, it's been so far eerily similar to that experience, and like equally as funny. I don't know. We have some pretty ridiculous things. Starting a company is insane. I would recommend it, but yeah, it's so hard and stressful, but it's super fun at the end of the day.
Chad, I have one question, like how much did the operating system knowledge help you? And which parts of the operating system knowledge helped you?
That's interesting, actually. A lot. Yeah, I mean, to answer that, a lot. Like the bug that came up with like the fact that a compiler would do tree trimming, right? Like if you didn't even know that existed, that bug would have been impossible to find. I think threading actually, and understanding like concurrency, and I think I've given 3 or 4 lessons on semaphores and mutexes like to employees. That like things come up and I'm like, oh my God, I'm like, you guys like just put a semaphore, and they just like, you know, have this puzzled look, and I'm like, oh my God, like clearly, you know, we have some resource contention. So one of the things like on our doors, right? The door is only ever in the state locked or unlocked, right? That's it. But we have, say, 5 employees connected to the same door that can all hit lock and unlock. So being able to actually manage that, you know, you need the exact principles that come from operating systems. We have resource contention, and you need to make sure that the state you're reporting is always the correct state, because it'd be pretty tragic if you think it's locked and it's unlocked. Like, so yeah, I think that the biggest thing is like threading, resource contention, and just dealing with the fact that multiple things are going to be talking to one thing.
Were there anything that you learned in the operating system class, but that was never used in your company? Or were there things that were overemphasized in the class, but in reality they are never useful?
I don't know. I mean, like most people think MIPS. I know we did our OS class in MIPS. We use MIPS. Like we our one embedded system ran on MIPS. The Omega processor ran MIPS. So even MIPS turned out to be useful. I'm like, yeah, that's no problem. Can look at some temporary registers. There's nothing that stands out as like that was totally worthless. Like the graduate level OS class, we built our own file system. I think OS is one of those things that like it removes the mystique of like what happens when I make this call, right? And just knowing helps you, like when things don't go right, you actually have some insight as to like, oh, there's probably, you know, this wasn't implemented correctly in the kernel or something, right? So I think, I mean, the fact that it's like the foundation of what you write everything else on. It's been so long since I took an undergrad OS course though. Like I don't remember specifically what was useless, but I remember the useful things for sure were just like semaphores, mutexes, concurrency, understanding kind of what a driver does, and that interface is really nice because like ultimately you're going to write something that talks to a thing, right? It's going to talk to a speaker or something. And it's going to not work because, like I said, unfortunately, bugs are inevitable. And even if it's not in your code, they're just as painful, probably more painful if you didn't write it. Yeah, so I think it's really valuable. And actually, like the writing a file system, that one's really useful. Because like there's so many times that things come up randomly where you're like, oh yeah, it's just like the inode is corrupt or like some weird thing, right? It's like, it's really nice just to have some insight into how it works.
Nice. And were there like, do you guys ever use like strace or tracing system calls, understanding like how this, like a library that you use to communicate with the operating system to debug it? Were there any such instances?
I've only had to use it on our own code. I had to crack open strace and like, what is going on? I don't understand. Yeah, not so much. Like most of the stuff we're doing is Bluetooth based. So we're looking at like HCI commands, and a lot of the like you can use console in OS X that has like a pretty nice output, pretty clean output. BTMon in Linux that gives you like kind of the level that we want. We haven't really seen many problems come up lower than that, but that kind of visibility is like critical to see like what's going on the HCI level. And then like the physical layer of Bluetooth, right? Like actually having scanners and Ubertooth for like sniffing traffic and things like that.
You guys use Ubertooth?
We have one.
Oh, wow. I see.
Yeah, we have a scanning app made by Nordic that we really like though, just for basic like Bluetooth low energy scanning.
Yeah. I had to like, I was like,
You know the NRF,
yeah, NRF, yeah.
something. I don't know, but that's our like go-to. NRF Connect. It's one of my top 5 apps.
I see. Yeah, so we had to do that for one of our tracking projects, but we used Raspberry Pi and measured the power, but it's way too different. Like BLE consumes like it's like order of magnitude less power than Bluetooth.
Yes. Yeah, that's what people always ask me. Like, is this going to drain my battery? Like, no, it's not. BLE is highly efficient. Like, yes, but you won't notice it. Like, you having your screen on for 3 minutes to watch a YouTube video is way more of a problem.
Nice. So were there were there any features that you needed from the operating system, but they were not present?
That we needed from the OS.
Yeah.
So again, I mean, we've just been like working really low level on Bluetooth stuff right now. So I think unfortunately that'll be most of my comparisons. Yeah, the one that we did in the Linux kernel, or like for BlueZ, is actually like reasonably low level. So the way BLE works is you have characteristics that you can subscribe to, and then you just send and receive data from them, right? And it's very asymmetric. So if you're the one broadcasting the characteristic, you're the only one you can get written to. And the way that you reply is you notify them that I changed the value changed from 5 to 6. Bluetooth, or like the Linux kernel, currently only lets you notify everybody at once. And we wanted to be able to notify just one person, which seems reasonable. That didn't exist. So we actually wrote that functionality in, and that's the merge request we're going to have, so that you can say, okay, I have 5 people connected. I only want to notify one of them though. And you can now do that. So like that kind of stuff. Yeah, and then the other stuff, I guess that the operating system, OS X is interesting. It doesn't have anything missing, but they've gotten so crazy about code signing and code integrity that developing for Apple anything it's just become an absolute nightmare.
Wow.
It's a disaster. So to give you an idea, for us to develop for the iPhone, so the iPhone will only run signed code. Makes sense. That's fine, right? But they don't have a way to have like a team private key.
Mm-hmm.
So what is suggested online, and what we unfortunately do, is we have one computer dedicated to building the iPhone app. All of our keys, that computer has a private key that's stored on Git that has a password that we can all pull locally, and then we all have the same private key. So we don't actually know who deployed the app, which is insane. It just comes out as like iOS deploy. And then, yeah, the whole thing that they've done with like code signing is just really wild. Like, I get their logic from an operating system point of view, right? I only want trusted code, but it's like they never thought that people would work in more than one to develop anything for Apple products. Like it's weird. And this is what companies are doing to get around this.
So all the companies do the same thing?
Yeah, so they use this thing called Fastlane and Match for iPhone development.
Mm-hmm.
And we run into the same thing on Macs. So like everything has to be code signed. So we have our entire bundle, little thing that you're gonna like download and drag into applications. That has to be code signed. That depended on Python. So then Python had to be code signed with our stuff. Like it just gets crazy. The development process gets really wild from a security perspective. So yeah, I think the one thing they don't have is the support for, code, like team development of code. That's kind of annoying. Like, just give us a team key. Which OS is the easiest to work with for a beginner to work on an OS project? I mean, I guess Linux. If I had to pick one, I would say, yeah, Linux. Everything's open source. It's kind of easy-ish, but you can find examples pretty quick. I know I took like a Linux kernel driver little mini class, and by the end of that week, I was like pretty competent on like generally how the kernel interacted and all of that stuff. OS X for all the code signing reasons, it's not beginner friendly.
Oh, hello, Chad. I also had one question. First of all,
Yeah.
Thank you for taking the time of speaking with us. And my question is, you mentioned that this started as your kind of personal project. At which point did you decide like, oh, this project is actually a commercial product that can help millions of people around the world? And I can make I could commercialize this product, this idea.
Yeah, I was at MIT, and when I was at Lincoln Laboratory, they have like internal research funding that you can apply to. So I applied like every year. I'm like, look, I really want the money to like release stupid passwords. I'm sick of it. Got another guy on board. We got like $400,000 of internal money. They're like, hey, take 50% of your time every day and go ahead and work on your project. And then throughout that year, we got to the end of it and they pushed hard. They're like, you should file a patent. And so MIT filed and owns the patent. They're like, you developed this and you work here, we'll file the patent. And then I don't want to say like they encouraged me to leave because that's not true, but they encouraged me to like seriously consider starting a company. That like, hey, this is commercializable. If you want to go start the company, go do it. And you're always welcome to come back, right? Like they're really encouraging of like, they want their tech to go change the world. And then the founders to come back to MIT or whatever. So that was probably the first moment where I was like, oh, maybe this isn't just my fun project. And then throughout when I was in grad school, like Arvind said, I just worked on it kind of on the side. It wasn't really my main research project, and had it working on our lab and started using it. And I'm like, okay, I actually started looking at the market, and the physical access control market, I think, is where it's most needed. Just like getting indoors with your phone. I think, that's an easy win that like people want to do anyway, and commercially viable. And then ultimately, I want to get to that point where everyone has a private key on their phone and you can use that for everything. Like you could do e-voting and all sorts of awesome stuff.
Awesome, thank you. And in terms of where you're at the moment, are you more focused on like individuals, targeting companies? You mentioned you're trying to pair up with Google. But in terms of your expansion, like what do you see is your roadmap, your avenue?
Yeah, companies, B2B. So I think that the kind of vision is you get hired at a company, you bring your phone to work, and that's everything. I'll get you in the office, I'll log you into your computer, and then we integrate with like Google Workspace. So if you already use, like if you log into your Gmail and you're an employee at Authenticate, it'll use our app instead of your password. And if you use Google Workspace, you can import all of your users from there automatically. So like, I don't know if Purdue uses Tweet or not, but if they were to use it, they just like, oh, import, all of the CS students, bam, you get an email, you're up and running. All CS students have access to the CS building, boom, done.
Awesome, thank you.
Yeah, no problem.
Purdue uses Office 365. Yeah.
What's that?
Purdue uses Office 365.
Oh, went with the Microsoft, huh?
Stuff, yeah.
We'll integrate with that too. They're all the same. There's some bearer token and HTTP request that goes out and they give you the list of users. How useful is a master's PhD for your career? Would I suggest it to complete soon after undergrad? That's an interesting one. This soon after undergrad is the interesting question there. I'll get to the other one in a second. I went straight from undergrad to a PhD. I also was 1 year, so I started my PhD when I was 21, so I was pretty young. It all depends on your advisor. And I think that wasn't emphasized enough when I was applying. If you get a really good advisor that you mesh with, like it's just going to be a fun time. Like regardless of your career, you'll have a great time. You'll get to do cool stuff. And it lets you explore, your own ideas. Ideally, if you get into a cool lab that does what you like. So like make sure that if you're going for a PhD, they actually work on what you like to work on, because it's not as flexible as it's advertised. It's not like, oh, you start a PhD and you work on anything you want. Most labs, you work on what they have funding for. So you have to make sure before you go in that that's true. I think we were very lucky at the SEC lab that we kind of did get that experience where you work on whatever you want, but that's kind of rare. And it's only because our advisors are who they are. They kind of, no one will touch them or tell them no, so they can just let us run wild. And then did it help my career? I think it did. The master's definitely did, just to get a little more focus and beef up your knowledge. The PhD did in different ways. So the things you get out of the PhD is like, it's grit training to the max. Like you really just have to be persistent and not stop on a project. And like you'll go through some depression, it's gonna suck. But then like after that, I don't how do you describe it? It's one of those things like once you've been through that battle, like everything else feels easy. Like I'm starting a company, it's subjectively the hardest thing I've done in my life, but it's like, I'm only 1 year in, right? The PhD, I did 3.5 and then another 5. It's like, this isn't even getting started, like whatever. I'm ready for it. So yeah, I mean, if you get the freedom to work on cool things, I think it's totally worth it. The degree itself doesn't feel that rewarding, but I had a really good time while I was there, met cool people, have great professional connections like this coming out of it. So yeah, that being said, going to get a job and then coming back, it's really hard to do, to quit your job, because we get paid a lot in our industry. But I felt way better prepared for the PhD. Having worked first, I felt like it was just easier. Like everything felt easier. I knew that if it didn't work out, I could go back to a job I loved. And like, I don't know, I just came in with more confidence that I was like, oh, I worked, at a company before this, and I kind of get it. So I think that one's a personal decision. Like if you feel like you're ready, just go for it. But I do think there's an advantage of having work experience. I think most of the people in our lab did have a job first. And I think you're a little more self-sufficient. Like you have a couple of years, just kind of figure it out. And then you're good at software engineering before you come into the science part of it. Diversifying skills. Right. That's a good question. So that's the difference between kind of the master's and the PhD, right? A master's, you'll come out with a decent amount of breadth, but no real like expertise. Yeah, I mean, I think the one thing that, like I said, to focus on that I didn't focus on earlier is the software engineering part, like just being good with your tools. Because then regardless of what you pick to focus on, you'll be efficient at it and you'll be good at it. I feel like a big difference just every day now, like literally the fact that I can do like DW to delete a word. I don't know how I lived my whole life, like hitting backspace, 17 times on a long string. Like it's insane. And then it's your career, right? If you're in security, you kind of necessarily have to be diverse. If you want to go into AI, maybe just like specific type of neural networks is your jam and that's your thing. I don't think there's a blanket answer to that one.
Oh, yeah. This is very interesting. Anybody have any other questions?
Yeah, I hope this was useful. I wasn't sure what the format was supposed to be, so I'm just sharing life.
No, this is definitely useful. Like in the class, we constantly we learn a lot of these concepts, but it's really interesting to see how they are really useful. For instance, like when I was teaching semaphores, or even when I'm learning these semaphores, I never knew that these things would play such an important role in real life, right? Like, because the problems themselves are pretty nonsensical if you think about it, right? Dining philosophers, who would why? Everybody will get a 4. No, everybody will buy 10 4s. It's fine. You see?
Yeah.
the problem.
Yeah, but making sure the door is always locked, whether it was unlocked by a phone or a motion sensor or a button, like, yeah, you need a mutex there for sure. You got to like, you got to know how many times people hit unlock and make sure the number of times you hit lock is, equal to that number.
Yeah, it's interesting to see. Like especially when you are developing from the scratch, it's like you need to figure all these things by your own, right? Like if you go to big companies, I think they would have some policy or like some methodology to find bugs and like fix bugs. Whereas in this case, like you actually went through every part of software engineering by yourself, right? That's really
Yeah, and I mean, I guess the weird thing that I've found is the best way to find bugs is customers. They're so much better than any static or dynamic analysis. Like you put this thing in people's hands and you're like, how on earth did you get the code to do that? Like what code path did this thing just go down? Like, oh my God. And you're like, I can't reproduce it, but I can fix it. So like, moving on, null pointer is now checked, who knows?
Wow, that's true.
Yeah, so that's been interesting. They're very good fuzzers.
Yeah. Yeah, because we can only think about stuff that we have written, right? We cannot think out of the box just because like we have been involved in the product so much that.
Exactly.
It's true. Very nice.
And even watching people use something that you built, it's the most frustrating experience on earth. Like you swear they're messing with you. Like, oh yeah, how do I add a user? And they're hovering their mouse over like the add user button. And they're like, okay, just click add user. Oh, where do I click that? The big button your mouse is on. Like just click, like what are you doing? So yeah, it's funny to like what you think is true and what is actually true are very frequently different. You're like, okay, well, make that button more obvious. And we're still like very young, right? In this phase, we're only a year in. So like those kind of lessons are just going to keep piling up.
Yeah. I really hope like you get to a point where these things maybe like you can make a video tutorial of this or like just a vlog of the things that you're going through now. I think it will be very helpful for even for entrepreneurs, students, everyone, right? Because these things are very valuable and fresh in your mind.
Yeah, I should take time, maybe like once a month, and just give like a little, here's what the heck's going on.
Yeah, just do a vlog, video log. That would be very helpful.
Yeah, because it's a pretty wild. I mean, it literally is like episodes of Silicon Valley, or like it. It's an insane thing to try to do.
Hey, you can do your own Silicon Valley. Why not? Yeah.
Yeah, YouTube once a week. Tune in.
There you go.
Yeah, I probably should start doing that though. We were talking about that, like to document what we're trying to do, because especially technically, it's such a complicated thing to build. This like fully distributed system that has a really high consequence if it fails. With all of this crypto going on, and like, yeah, we've locked people out of their offices for sure. Gotten calls like, hey, what's up? One guy's had to put a bike lock on their back door for a week because like our hardware just failed. And yeah, that one failed because we had it infinitely updating. So it would just like the CPU was just crushing itself and then it would overheat and die. And we're like, oh my God.
So you guys had to go to the field and like bring it down.
Yeah.
Okay.
Like more frequently than we'd like. We're in people's office, like ripping stuff off the wall and putting new hardware on there. Wow. Like, oh, just go figure out what's wrong back in the office.
Yeah. Thank you, Chad. It was really amazing to know your journey, and thank you for sharing all the details and patiently answering all our questions.
Yeah, man, of course. This is a blast. Thanks for inviting me.
Okay. I think I think there is just one more question. Okay.
That's for you.
Thank you, Chad. Thank you for your time we had. It was really interesting knowing about your story. I'm also a big
Cool.
Notion user. Those Kanban boards are amazing.
Oh my God, Notion it's sick. I love it.
It's brilliant the way they integrated like Excel with something like Trello into one
Yeah.
app. That's really interesting.
Yeah, and even our how-to guides and stuff we put on Notion. We're like, why are we going to take the time to like rewrite these? Like they look clean, they come out nice. You share them publicly. I'm like, this it's a great platform. Everyone can comment on them. They're killing
And-
it. They've been getting too many users though. It's been slow like the past month.
Mhm. You
Word
should
is out.
definitely make a TikTok. If you want to make vlogs about your content, just make a TikTok account and then share like 5-minute videos every day.
Okay, I need to start doing that. That's yeah. I think I might take that advice. Do it like once a week, little rehash of what's going on in the startup world.
Yeah, I think that-
It's
let
good
you guys
marketing
go.
as well. Good marketing.
I'll send you the link if I start doing that.
yeah. Okay. Guess that's it. Chad, have a
All
nice
right, dude.
day. Thank you.
Thank you.
Will do. Always a pleasure.
Bye.
See ya.